Good morning, good afternoon, good evening. Welcome to Hands on SAP Dev, another episode of the DJ Q Macro. We're back. We're back. In fact, I don't think we were ever away, really. We've had a bit of a pause from the art and science of CAP with Daniel Hutzel because Daniel was off sick. And then he's got involved in other things as well, which is keeping him even more busy than usual. So hopefully, we'll have some more episodes in the future with Daniel on the art and science of CAP, because I don't know about you, but I find it a little bit mind-blowing. It's amazing. I'm learning so much, and I hope you are too. Anyway, welcome. Thank you, everybody, for joining. We've got an hour, as usual. And by the way, I was thinking, well, shall I do one today? Because I was in Germany this week, and I wasn't getting back until late last night and everything. It's like, and also, I'm going to be away on vacation for the next 2 or maybe 3 weeks. So, is it worth doing this one single sort of, standalone thing and then stop for a bit? But I thought, yes, why not? Because I've missed you all. Welcome, everybody. Visas in Thailand, and in fact, I've got the chat here, but I've also got the chat here. And welcome to Ulrich in Frankfurt in DE, Deutschland, and Mark Teisman. Good morning, to you in Kiel. Kiar, buongiorno to you in Brescia. Sudasan, good morning to you. And Antonio, good morning to you in Madrid. Amazing. So I met Antonio for the first time in person. He did a great talk on RDF, one of my favourite topics, actually. I was playing around with RDF a long time ago. Put in the chat, I mentioned this to Antonio in the coffee break. This was in SAP Inside Track Madrid week before last. It was a really good talk from Antonio, and I was thinking, wow, actually there is a link between RDF and sort of CAP in a way, but more OData. Put in the chat what you think that link might be. How do you get from RDF to OData? It's quite an interesting journey or connection. Good morning to you, Chanakya. Hello, long-time friend of the channel, Chanakya. And good morning, Christian Drum, an old-time friend. Welcome to you in Aachen, AP. Good morning to you in Dusseldorf, Swedish. Good morning to you in India, Helmut. Good morning to you in Brunswick, Braunschweig in Germany. Visa says there's an earthquake here. Hope everybody's doing well. Hope you're okay, Visa. Stay safe. Heritage message retracted. Good morning to you anyway. Vishal, good afternoon to you, sir. And Heritage, hello. Where are you now with your boat? Good question. So I'm currently on the Macclesfield Canal, which is sort of, if you look at the northwest of England, Manchester, and then south of Manchester is Cheshire and the Cheshire Plains, and the Macclesfield Canal goes more or less sort of north-south down towards sort of, Stoke, Staffordshire area. So that's where I am at the moment. I've been leaving my boat here in the marina while I've been travelling, and I'm going to be around here for a while, maybe for the next few weeks, because I'm helping my sister out with something, and she lives locally in Manchester. So anyway, so thank you for asking, Heritage. Ajay, good morning, a good friend and colleague of mine in the team. Kazatis, good morning. Yes, exactly. It was so SAP Inside Track Madrid was brilliant. It was the week before last, and I met so many people I sort of knew online, but I've never really met. The multiple Antonios, Roberto. Lots of people, and here to capire, exactly. So Chiara would be very happy with your statement there, Kazatis. Oh gosh, it's absolutely chucking it down. I was going to go for a run after this, and I'm going to have a very wet run. Matthias, a long-time friend of the show, good morning to you in Meskede in Sauerland, Germany, and Duma, good morning to you. Wow, brilliant to see you all here. So what I want to do is to start off. Notice that it says there, let's explore functional programming, part 1. Hey, Mikhailo, good morning to you in Lviv. Welcome and welcome. So start exploring functional programming. Now, I talk a lot about functional programming, generally wave my arms about and everything, and I want to stress that this is part 1. And this feels as though it's the sort of topic that we collectively, Heiner, Heider, good morning to you, collectively can sort of dip in and out of over the next few weeks, months, whatever, and intersperse episodes of this series with other things we're doing, you know, so we might slot in some sessions with Daniel on the art and science, but also somebody pinged me the other day, and I've been thinking about this for a while. Maybe later this year, what I was thinking of moving to is sort of, this is not the right phrase, but day 2, i.e. Within the CAP world, deployment, moving from design time to runtime, Cloud Foundry, the different options, what we have to think about, looking at the way things run on Cloud Foundry, production style configuration and so on. So let me know if that would be interesting. Everybody is here for a functional programming. Yes, exactly. How cool is that? Christine, you're so right. Anyway, so I'm going to a cup of coffee. And I want to start out sort of with the basics. If you're not aware, what I did, let me switch to here. If you're not aware, not in preparation for this, but thinking about this, I thought, oh, I've got a lot of stuff, maybe I could share that, it would help people. And I've written a lot of stuff in the past about functional programming, you know, whether that's sort of general concepts, which we'll talk about shortly, whether that is, you know, particular focus on, I did a lot of sort of UI5 a long time ago, and I did a lot of stuff, you know, saying this is how you can make your UI5 JavaScript in the UI5 context more stable with functional techniques. And I did a hands-on thing, for example, at where was that, in Bangalore maybe, I can't remember, I don't know, and so there's a lot of stuff. One thing, here we go, if we look at this, for example, presentation, okay, thank you, Christian, for letting me know deployment would be a great topic. Okay, cool, that's good to know. So I'm not going to go through these slides. This is not what this show is about. But on these slides, can anybody tell me, by the way, who that is? I mean, I think some people have, you know, will know, but I think this person here, you know, has an amazing mind, has had a massive influence directly and indirectly on CAP, interestingly, on the REPL, and on functional programming. But so let me know in the chat who this person is. But I just want to sort of throw some concepts in the air, and over the course of the, you know, this episode and sort of subsequent episodes in this series, I want to make sure we understand what they are and can see them and feel comfortable with them and apply them. Functions are values. I'm going to sort of go through these. I'm not going to explain what they are yet, but I want to sort of start to put sort of words and phrases in your mind. First class functions. I'm going to come back to that when I'm going to go back into the CDS REPL shortly, just to kick us off and talk a little bit about what we touched on with Daniel in the Art and Science of CAP about queries being first class. Okay, again, put in the chat, and this is what is my favorite thing about the Hands-on SAP Dev Show. It's you lot and the chat. So put in the chat what your thoughts are, what your questions are, what your comments are, who you think that person was, and also what you think or what you know to be the meaning of first class functions in the same sense, or in the same sort of ballpark. We talk often about higher order functions. I mean, it sounds very, very posh and very sort of technical, but we're talking about what that means as well. Pure functions and referential transparency. We'll talk about that a little bit later on in this series. Immutability, that's important as well, where data doesn't change and what that sort of implies. Composability. Now that composability is, I think, at the heart of a lot of the stuff that we're going to be covering early doors, i.e., you know, in the early episodes here. The ability to compose, to put little building blocks together to make new things, a little bit like Lego. You know, I don't want to use that term, that overuse that sort of metaphor, but it is like you have small building blocks and you can create new building blocks from the original building blocks and combine those together. And this is at the heart of one of the major superpowers of functional programming. So the ability to compose functions, and there are certain techniques and approaches and aspects of functional programming that lend themselves to help out with this whole idea of composability. Now, this is all very sort of high-level theory. Hopefully, this will, will land this, starting with this episode, but going forward. So, Sudarshan, good work, John McCarthy. That is John McCarthy, the father of Lisp, one of the first languages ever, actually, along with Fortran and so on, but from a different sort of ancestry. And functional programming has its roots in Lisp, of course, as does the concept of a REPL, the read, evaluate, print loop thing. Anyway, Papa of Lisp, Chanakya, excellent, good work, Papa of Lisp. Oh, and there we go, Robin Vanethoff in the house, fantastic, welcome, and great to have you, Robin. And Yavuz, good morning. I wish this would be more of a series of the previous Back to Basics. The one with Daniel was a bit heavy. The one with Daniel, okay, well that's good feedback. Thank you, Yavuz. Maybe let me know in the chat if the notes that I've written in the form of blog post, if they help or they make it worse. If I could make the notes a little bit different. But yeah, I mean, it is quite heavy. I agree. I don't disagree. But let me know. Let me know, other people. Let me know what you thought of the art and science of CAP and so on. Function chaining. Again, that's sort of in the same realm as composability. Closures. Now, I want to talk about closures today. Okay, who here has heard of closures and knows what they are or would like to know what they are? It sounds, again, very technical and very sort of, oh yeah, computer science, but it's not. It's a beautiful thing. So we'll talk about closures. Recursion. If you need to learn about recursion, first learn about recursion. Classic joke. Currying and partial application and point free. We're going to be talking about, hopefully, covering those things. And we're going to sort of hopefully become comfortable with those concepts and those terms over the course of, this series. So Vishal says, yes, going through the notes is helpful if we want to understand Daniel, if we want to understand what's in Daniel's brain. Exactly. Okay. Now, so I'm going to leave that because that's those are slides there. So if you, where's the URL? Let me share the URL, put it down there, for example. There we go. And there's the URL to that. And now, if you go back there, I want to start out maybe by looking at just a couple of things from this blog post here, which I wrote in conjunction with a talk I gave at SAP Inside Track Madrid week before last, basically 2 weeks, no, last Friday. Yeah, last Friday. Which is all about the CDS REPL. Okay, so you can have a look at this as well. You obviously can go to the main thing here, and there we go. So AP says, notes are very helpful, gives more structure, behind the scenes references. Yes, behind the scenes references. I hope you don't mind my random, crazy cultural references. I quite enjoy putting those in there. Now, Lambda functions are also falling. Vishal, brilliant, excellent. Yes, so that's a great comment and a great question. Thank you. This is the sort of thing I love. Yes, Lambda functions. A Lambda function, basically. So the term lambda comes from, of course, lambda expressions, which come from the Lisp area, which is sort of heavily informed by lambda calculus, right? Which is sort of computing as we know it has, again, two parallel ancestry lines. We have the sort of von Neumann approach, more towards the sort of the Turing machine sort of procedural, but we also have this lambda calculus, which is sort of related also to sort of generally to sort of category theory and mathematics, which is sort of informs this sort of quite orthogonal functional programming style. Okay, so in a lambda function today, basically you can sort of equate that to an anonymous function, a function that you sort of define on the fly, and I'm hoping to show that, or I'll point it out. Hopefully I'll remember to point it out, because I'm going to be using a lambda function. We use lambda functions all the time. In fact, let's maybe use the CDS REPL to explore what a lambda function is. 8:14, come on, DJ, stop rambling. God, it's me. But querying in this section of the blog post that accompanies my talk on the CDS REPL. Let me switch to there, the CDS REPL. I've started the CDS REPL already. Capire, exactly, and that's the emoji you have to use. The capire, exactly. Understand it. I've got CDS REPL running, and I'm running the bookshop. I sort of invoke this with CDS REPL-R bookshop. As you can see here, started the bookshop service, and now if we, for example, well, do this one, catalog service, or let's do a. Sorry, I think I hit the microphone there. Let's do this one here, right? CDS QL. There. Let's go and there. CDS QL, select ID name from authors. Now, a little bit bigger. We can afford to have big things here, right? So let me know in the chat if that is big enough. This is a function, cds.ql, and you can pass it a template string, which is denoted by the backticks, inside of which you can have this sort of query, the CDSQL expression. What the CDSQL function will do, it returns a query object. Okay, and we can see the query object here in terms of this structure, and this query object has a certain, or is denoted in a certain notation. That notation is called CQN. The meaning for C changes a little bit, but let's call it CDS query notation or conceptual query notation, as CQL is conceptual query language. CDS query language. Anyway, Furkan, welcome. I am a junior mid-ABAP developer. I want to know that this session would be a good step to start CAP or not. I think so. I mean, that we also have, Furkan, we also have a whole lot of episodes in a Back to Basics with CAP, which go check out the channel, this YouTube channel, SAP Developers YouTube channel. There's a Back to Basics series with 20 episodes. That would also be good, but functional programming as a foundational bit of knowledge is always useful, I would say. So welcome, and I hope you stay around. So that's CQN. Now, what we can do with that is we can assign it authors. We can assign it to a variable, and we can pass it around, and we can also await. You can actually execute it. Await authors. There we go. So that is a really simple, stupid example of how something is first class if you can pass it, or assign it to a variable, or have it generated from a function, or even pass it into a function. We'll do that shortly, okay? And if you can execute it, right? So something that you can sort of deal with as a piece of data, just like anything else, like an object or an array or something like that, is first class if you can assign it, pass it around, and so on. So the concept of first class queries is in CAP, and the concept of first class functions, or the concept that functions are first class citizens, i.e. you can assign functions to variables, constants, whatever. You can pass functions in a call to another, you can pass a function into a call to another function, and you can also create a function. You can have a function spit out as its output, as its return value, a function. This is a very, very important concept in functional programming, and again, it's sort of the basis of, it's almost like the bricks and mortar of everything that builds up to this whole idea of composability. Anyway, in fact, why don't we, while we're still here in the CDS REPL, exactly. This is what I love about this show. You are all helping me explore this and explain this. So Chanakia says higher order functions, which is one of the phrases that was on those slides. So a higher order function. By the way, before I explain what higher order functions are, I want to explain or justify why I'm talking about these technical names: higher order functions, first class functions, immutability, composability, partial application, currying, all these different things, closures. Because I find that if I'm trying to learn something and I'm reading through some documentation and it uses, that documentation or that blog post uses these phrases, it helps a lot if I know what these phrases mean, and I can sort of construct this sort of understanding in my brain using the right terms. Okay, so I think it's important to know what these things are. So as Chanakya says, higher order functions. What is a higher order function? A higher order function is a function that can receive as an argument a function, one or more functions, and or also can emit a function as its result. Okay, and we're going to do that. We're going to do that shortly. In fact, what we're going to do is we're going to use, why don't we use a higher order function right now here. So Vishal says callback functions in JavaScript are also then first class functions. Okay, brilliant. Again, brilliant, brilliant, brilliant. In JavaScript, all functions are first class, i.e. all functions are assignable to variables and pass-inable to other functions and also generatable from functions. Okay, so in general, JavaScript has support for first class functions or functions as first class citizens. And there's a brilliant link that Vishal says here, callback functions. I'm sure we've all heard of the phrase callback. Basically, it's a function that you specify that you want to be called when something happens, as in, a callback. This is sort of also related to webhooks, of course, and then that moves us on to sort of, the integration world and everything. But anyway, a webhook is basically a callback function. And a callback function is sort of defined, the essence of a callback function is a function that you pass in as an argument to another function, i.e. in the higher order function sort of context. So another thing that I showed here, let's go to the thing, I've just added this about 10 minutes ago, this sort of table of contents, because I was sick of scrolling up and down. I added it so fast I got a typo, digging deeper. I'll change that, shall I, in a minute. So digging deeper, what I did as well in SAP Inside Track Madrid was create a new service and then define a handler just to show that, there's nothing underneath. The cap is just the beautiful thing. So let's do that now. If I were to say, for example, my service equals, I'm going to make that a little bit bigger. My service equals new CDS.service. Okay? An empty service. And then we have handlers. Remember, we have handlers for services. We have handlers for events. Let's use the sort of generic term. And we have different phases of, for example, a request. We have events that are emitted, and that's just an on thing. A little bit like, an action or a function in OData protocol terminology. But in more general in more specific request terms, a request is sort of processed in 3 phases. It has a before phase, an on phase, and an after phase. Before the request is sort of handled fully, after the request has been handled fully, and on is the handling of the main handling of the request. So, in a before phase, you might have, some data validation or whatever, or some enhancements of the input data and everything. And after, you might sort of want to tack on some stuff or change something before the response goes back out to the requester. And the on is the main handler. Anyway, that's by the by. We're not really doing cap stuff today. Oh, thank you, Weezers. I can listen to this kind of discussion all day. I really enjoyed it. Brilliant, brilliant. But it's all because of you lot. So keep chatting, keep putting your comments and questions and opinions. I love opinions. I've got lots of opinions myself. Now, what we can say is CDS service a superclass of application service? Maybe it's a great digression. I'm going to leave it. Maybe come back to that another time, Chanakya, because I know that if we go and digress and look into the Capira documentation, we are going to go down a rabbit hole we may never get out. So thank you. It's a brilliant interjection. In fact, why don't you look it up? Have a look on the Capira, because the website is brilliant. The documentations are brilliant. So all I'm going to do is I'm going to say it's my service dot before. Okay, and let's have, first of all, you define. So I'm calling a function. I'm calling this function before. i.e. I want to create a handler for the before phase in this service for an event called, I don't know, banana, my favorite sort of test word. And what do I want to do? I want to have something happen. I want to create a callback function. Okay, so let's try and use as many of the terms that we've seen briefly in the last 20 minutes here. So I'm calling this before is a function. It's a higher order function. We know it's a higher order function because the second argument that we're going to supply, the first argument is a string, banana. The second argument is a function. We're passing a function in, okay? And this function is also a lambda function because it doesn't have a name. It's anonymous. It's defined on the fly. So, and again, I know that all of you, or many of you, will know this already sort of implicitly. But the point here for this very first episode is let's talk about these things that we already know and start to give names and attach the names and the terms to them. So we could say, for example, well, actually, let's, in my brain I'm thinking, shall we use a fat arrow function expression, or shall we use a more traditional thing? I'm going to, more traditional, first of all, function x console.log x, right? So all we're doing is we and this thing here, right, from there all the way along to there. Ooh, come on, highlight that. Oh, god damn it. There. That is our anonymous function. It's a function we've defined on the fly, and we're passing it in as the second argument to the before function. So let's do that. Okay. So now we can also see the definition of my service now has in the before property, it's got an array containing a single element, which is this before phase handler for the banana event. Okay, so now if we were to say, for example, my service dot send banana, and then pass it something like, you know, I don't know, life 42, answers the meaning of life, right? 42. There we go. In fact, let's get rid of the promise. Everything in JavaScript, everything in Node.js is sort of asynchronous. Let's sort of do that again, but let me just add await, just to get rid of the noise, this promise noise here, right? Await my service dot send banana and pass it some data, right? So we are now sending a request. The identity of that request, or the identity of that sort of event, is banana. So the before handler for that banana method, or because it's called method here because of course it's a request because we've used send rather than emit, but that's another story. Good morning, Andrew. Good morning and welcome, Andrew, good old friend of the channel. This line here, request open curly method banana data life 42, comes exactly from this function, this callback function, this anonymous function, this lambda function that we've supplied in the call to this higher order function before. Okay, now there's an example of a callback function, a lambda function. I just want to show you something though. Let's say we let's define something else. Let's define something else. 829. Oh my goodness. If we were to say my service dot on, let's do an after, and I want to sort of start us thinking just the very tiniest toe in the water of thinking about what composability and what currying and what partial application, what sort of universe these concepts live in. We don't know what they are yet. We're not going to talk about them specifically. Hey, Lawrence, good morning to you. That's okay if you're a little late. You're welcome. Haskell, Haskell. Yes. So in fact, in that URL I shared, the resources to functional programming in my blog there, that blog post that I published this week, some of the links are to some stuff that's got some Haskell in, and also some Elm. Elm is a beautiful language. some Haskell as well, which I learned from my son Joseph actually. So you know, and good morning to you, Ravi. Good morning and welcome. So I'm going to say this, right? Oh, in fact, let's do a. Oh, sorry, I didn't. Oh, sorry, I got that wrong, didn't I? My service or after. Let's do banana, but let's do this, right? Let's first of all define a similar thing, but using the fat arrow. So let's get ourselves used to the different ways of defining a function. I could just say console.log x. There. That's a little bit more concise. There are differences between them. You know, for example, in the fat arrow function syntax expression syntax, you don't get access to this concept of this THIS, nor do you get things like the arguments, which is like this pseudo array of the things that get passed in. You do in this sort of older function style with you know, the function keyword there, curly braces. If there's only one expression in a fat arrow syntax function definition, you don't have to put curly braces, but if you do, you can do, but you have to put a return statement. Anyway, we'll deal with that as we go along. So let's define that, press enter. So now we've got, I've just seen this, Mafuga, good morning. So my service.send sends the event banana. It does, before catches with the ID banana and calls the handler. But yeah, exactly. So basically the service catches the event and looks through its list of handlers to see which handlers it needs to trigger, to call back as it were, to call depending on the identity of that event or that request. In this case, it's banana. Exactly right, Mafuga, exactly right. So now we've got this before handler. So if I say await my service.send, well, in fact, let's do that, right? So let's just prove that it's not going to get called all the time. Nothing happens because there's nothing. There are no handlers for the event or request. So now if I do that again, but change that back to banana, undefined. Oh, undefined. Ah, yes. Okay, here we go. Console. My service to after. Request banana. Ah, yes, because let's do that again. I think life 44. Yeah. So in the after. It's a slightly different. I should have done that a different way. Rather than try and explain that, let me do that a slightly different way. My service. Let's do this. Where are we? My service. Dot. What was it? Before banana x console dot log x there. There we go. So we now get two outputs because we've got two before handlers. Forget the after handler for now. I made a mistake there. We get two, but they're both defined differently. We're using this fat arrow function. I want to do one more. Before we move on to the normal Node.js REPL. Hey, welcome to you, Safta Mascan in Luxembourg. Welcome. I want to do one more thing, right? Because we've got this one here. Right, so now I'm going to say my service dot before banana, and I want you to think about this. What is going on? Let's see if that works first of all. 46, doesn't really matter. We get the same output. So we have these different definitions. We've got that one. We've also got that one. Well, in the before. That one, which is the fat arrow function expression syntax. And we've also got that one. Now, what is going on there? What is going on there? Well, if you see the difference, right? The difference is, let me just, let's just, this thing, right? That thing there is a function. It's an anonymous function, which is expecting one argument with the X parameter there. And then the body will just do this console log and use X, okay? This one, console.log, what is that? Well, let's have a look. Let's go down to here, console.log. In fact, let's run this. If we say, for example, X console.log X, just type it in, right? Bang. And also, in fact, the sort of the eager evaluation of the REPL tells us it's an anonymous function. If I type in console.log, the eager evaluation of the REPL will tell us it's a function, but it's not an anonymous function. It's got a name. It's called log, and it lives in the console object. Okay, so that is also a function. So basically, when you pass, when you define, let's get rid of that. When you define a function in flight, as it were, an anonymous function, and pass it as an argument to another function, as in higher order. So before is a higher order function. We're passing this anonymous, this lambda function, x fat arrow console.log x to it. What we really are defining is a function, and a function just sits there, and it has, arguments that it's expecting in the form of the parameters that we define, and it will do something, and it will emit something. Okay, so that is just as equally a function definition as let's put it in there, console.log, as that. Okay, does that make sense? Now, it's a little bit abstract, but hopefully that's a bit of a taster. So that's now go to NVIM episode 1. What I did, is it here, episode 1? Is it in there? I think it is, yes. Something wrong with my laptop. It's extremely poorly performing at the moment. It's an M2 chip as well. Anyway, there was this, maybe we'll talk about this another time. I wanted to sort of also land us 837. Maybe we could do this as well. 837. No, you know what? We'll do this another time. This was something I saw on LinkedIn this week, and it really annoyed me. I almost responded, but I thought I'm not going to respond. Somebody was saying, "Oh yeah, shorter code is not always easier to read," and they're saying, "Oh well," they were saying, "Oh well, this is a lot easier to read and understand as a developer than this." Okay, and I was going to talk about that and how I disagreed, but not because I think I'm really cool and functional programming is my thing and blah blah blah. No, it was a little bit of an unfair comparison because he was saying that this bit, it's like, what is that, right? But the whole point was, and we'll sort of do this another time, but the whole point was the composability angle of functional programming would suggest that instead of, but basically this is, this just adds the numbers together. We've got numbers 1, 2, 3, 4, 5 here. We've got total. Let's do it now. Let's do in fact, let's open up the REPL. REPL. I've got this new plugin that I can send things to the REPL. So we got nice sort of syntax highlighting here and multi-line editing rather than do it in the REPL itself, and I can send it across. Okay, so let me know if you want to. Never, Christian, you're right. Never respond to anything on LinkedIn. Exactly. DJ, no, don't. So let's send that in. Okay, so let's do that. So we can say here, look, we can see const nums equals 1, 2, 3, 4, 5. Let total would define this total, and we're using let. Now this is, I want to start thinking about immutability. All of a sudden, when I see let, my brain starts going, because that the value of total might change, and I've got to track that with my small brain through the life of the program execution, right? So that already for me is a bit of a, oh my goodness, this is going to be really hard to read or hard to reason about and hard to track. Okay. We define a total of 0 there, fine. And then we do the regular sort of, procedural, nothing wrong with it, nothing wrong. But we do the regular sort of procedural, let's define yet another variable that's going to change. Oh my goodness, we've got 2 variables changing now. It's like, it's like 2 plates spinning. already. So our brain is already tracking, oh, total could change over the course of this, and I is definitely going to change because I can already see it changing over here, I++, right? And we've got this loop. Yes, okay, we all see this loop and we all know what it's doing, but it's a lot of mechanics, right, that we don't really want to have to think about as a developer, right? And we're adding, you know, the ith value of the nums array into total, and we get 15, okay? Now, actually, it just turns out that this 15 is emitted because of the last iteration within this for loop. Anyway, what they were saying was, oh, this is much easier to read than this. Now, if I send that one there, bang, get 15 as well. But that, first of all, is a deliberate expression. We are calling a function. We're calling the mother of all functions, reduce. We could do a whole series on the reduce function because it's the function, the building block of many, many other functions in the functional programming world. You can do everything with reduce, really. So reduce is a function that will, shall I use the word iterate? Yeah, iterate. Will iterate over, let's use the word iterate for now, iterate over a series of values in an array. And it will use a function that you give it, which in this case is this thing here, to work out a value. Now that value can be, you know, a single scalar value in this case, but reduce, you know, the idea of the word reduce in my brain and most people's brains has an idea of, you know, reducing it to a small thing, reduce, right? But it doesn't have to. You can construct superstructures with the reduce if you wanted to. Okay, there's another very, very similar, strongly related function called fold. Okay, and fold left and fold right, which is I think it's a better term for what reduce does. But anyway, we won't get there yet. But fold is a function in functional programming which is very similar to reduce, and it sort of folds the data in onto itself like this. So what's going on here? We have this anonymous function. We've got this lambda function that we're passing to reduce. So again, reduce is a higher order function because it takes a function as an argument. The way that JavaScript in general, enables these sort of functional programming style or themed functions to work is that it's a function on it's a method on the prototype of an array. Okay, so nums is an array, and you can, for example, have, you know, nums dot, let's do this, right? So we got nums dot length, right? Nums dot length 5, right? Okay, so we get nums dot whatever, you know, whatever, but you can also extend the prototype. So array dot prototype dot reduce, is that a thing? Yeah, it's a function. Okay, so it's a method that is available on everything that is an array. Okay, anyway, so yeah, there is a particular amount of code that a developer's brain can digest that by more or less is bad at the same time. I mean, that's a brilliant comment. That's a brilliant comment, Yavos. Yes, and in fact that reminds me to DJ, get back on track. What I would say is, yes, this can be a little bit sort of, what is going on there? But actually, of course, you know, in the same way, that's a pattern. I can see that pattern. We'll explain what the A and the X is in reduce another time. But basically what you would do in the concept of small building blocks, composability, you would say, for example, const sum equals okay. You would define a little building block function, then all you'd need to do is that. So let's run that. Let's just define that. Const sum is that. Okay, so we've now got this sum thing. So sum There, sum is a function. And now, 15. So that is what I would prefer to see from a composability, functional style approach to solving a very, very simple problem. Now that is eminently, arguably, more readable, more processable, you know, something that, as Yevos says, a developer's brain can digest more easily than this. Because this, when I look at this, there's a lot going on and there's things happening. There's a swan swimming along the water, and you've got the legs going under. It's like, what's going on underneath, right? Here, this is like solid state coding. Anyway, 8:45, perfect. What I want to do is just put a little bit of a toe in the water in terms of moving from this back to this whole idea of composability. I don't want to talk about currying and partial application yet, but the things that we're going to look at now are very relevant and very important building blocks to understand what and to use what currying is and partial application is and composability, right? So let's do this, right? Let's start from start. Are there any questions, by the way? Are there any questions? See, my coffee's gone cold. I'm going to write a function. I'm going to write something. I'll write a line. We'll still use this little nums, nums, what's it called? Constant, because that'll do. I'm going to write a function that returns a function. We've seen functions in the REPL over here that accept functions as arguments. Okay, so the before, when we define this before thing, where was it? That before is a function. It's a higher order function because it expects, you know, a string to represent the event name, and it expects a function, and we gave it a function there in the form, in this example, of console.log, which is a function which takes an argument. Right? Now, I'm going to write it in a really terse form first of all, and then we're going to sort of break it down. Let's move that over there a bit. We're going to break it down. And also I want to, in this, try and introduce the concept of a closure. Okay, so let's say we wanted to build. Let me write it out first. Let me write it out. So let's say const. Every time I begin a line with const, I feel happy because, you know, it's not going to change, right? So it's like you're building these solid brick building blocks. Andrew Barnard, solid state coding. Where did that come from? This small brain, solid state coding. It just feels like solid state radio. Solid, you know, there are no sort of things going woo. It's just like. Does that make sense? So if we say I'm going to define a function called make tax. I've been thinking about this morning, right? Make taxa. So, you know, we have values that are net of tax, and we have values that are, you know, including tax, gross, right? And there are different taxes in different countries and everything, and blah blah blah. So just as an example that is slightly better than, you know, hello world, I'm going to define this as a function that takes a percentage value, right? You know, a tax percentage value. Let's call it PCT, right? Oh, no, you've said that already. And what it will do. So there's the function, sort of the fat arrow expression. It will produce a function. I'll say that again. I'm defining a function here that takes a single argument, and I'm doing this as tersely, as succinctly, as small as possible. Then I'll sort of expand it. This function here will emit. In fact, let's do this, right? Let's just do that. PCT hello. Right? There's the simplest possible function that could work. And if I run that, define that function, right? And then I say make taxa. If I run that, if I sort of evaluate that, ask the REPL to evaluate it. Call it, sorry, like that. There. In fact, let's do a REPL clear. Let's do that again. There. Hello. So, in fact, I'll just do that. I'll leave const off because I want to redefine it in the REPL, and REPL says, oh, you've defined that already, blah blah blah. So we have a rerun it. I'll just leave it. So, but instead of producing a string when you run it, we're going to get it to produce a function. And what does that function look like? A function that takes an amount, right, and returns that amount multiplied by that percentage thing over 100, right? So, say it's 20%, VAT, value added tax in the UK is 20%, so it's £100. With VAT, it's £120, right? Now, amount times, amount added to there. Now, I'm going to run this, but then I'll sort of explain it as well. If I say then, and this, hopefully this will become clear, let's use const. And I'm going to now use that as a machine for building other functions. I'm going to compose another function now, or build another function called const add VAT equals make taxa 20. And then I'm going to say add VAT to £100. So let's do that, right? Let's say make taxa. Can I run the I might run into this const thing, but anyway, let's run that. There we go. Now, back so we got in one line. What has gone on there? What is going on? We've got this weird thing with two arrows. We've got this add VAT. Add VAT. What is add VAT? I wonder if I can just do a word. No, hold on. Word. Hey, that's cool. Yes, I can sort of highlight an individual word and say send it to the REPL. So add VAT. We've defined add VAT. What is add VAT? Well, add VAT is whatever make taxa emitted. So I'm going to highlight make taxa in my editor, send it to the REPL. Make taxa emits a function. And we've called make taxa to emit a function and stored that function, because all functions in JavaScript are first-class citizens, stored that function in add VAT. So now we've got a function in add VAT and we can call it. And of course, again, I like 853, perfect, yeah, okay. What we can do is, of course, we can say, I don't know, what's the, I'm just going to make a random sales tax up. Add DE sales tax. I have no idea. I should know. Sales tax equals make taxa, I don't know, 15. I have no idea, right? Sales tax. Not Germany sales. Anyway, it doesn't really matter, right? And then I'm going to say add DE, let's run that actually, add DE sales tax to £50, 50 euros. Run that. There we go. So we've got this with make taxa, we've got this sort of function builder. Now, what does this look like if written out in longer form? Okay, let's sort of be verbose. So we can say, let's leave that there for now. Make taxa, so I'm defining exactly the same, is a function that takes a single parameter, percentage. Then, actually, let's do this. Const multiplier equals that percentage over 100, right? Like that. Oh, make tariff 25. Oh, excellent. Make tariff 25. That's brilliant. Yes. And then what does this make taxa function have to do? It has to generate, return a function. So make taxa is a higher order function. It doesn't take a function, but it produces a function. So we'll say return a function definition. But a function definition that does what? Well, a function definition that takes an amount and returns that amount times multiplier. Now, there's a lot going on there. Hopefully, let me know in the chat if we're still all okay. 4 minutes to go. There's a lot going on there, but basically, let's get rid of that now. We can do this const. Okay, I've already defined it. Let's just long tax. Make long taxa, right? It's the same thing. It's the same thing. So let's just execute that and then try it. Make long. Let's make sure it still does what we expect. Taxa. What's it called? Add value added tax equals that. Oh, no, there. And then say add value. I've not set that. Value added tax to 100. 120. So it's the same thing. So let's pick apart. So yes, Daniel says, oh, Bern, sorry, I missed you, Bern. Sir, please teach us lambda expressions and anonymous functions. So yeah, so we are sort of doing the lambda expressions here in this commented out bit now, and anonymous functions. So these are anonymous functions because they don't have names. We don't give them names. We're just returning these sort of on the fly defined functions. So hopefully that makes a little bit of sense. So Daniel says, why not returning arrow functions here? It would be a single line. Exactly what I'm trying to do here. You know, that is all on a single line there. What I'm trying to do is sort of explain it in an expanded form so we hopefully maybe feel a little bit more comfortable with it, so we know really what it is. So, and the key thing is, what is this multiplier here? It's a constant. Where is this multiplier defined? It's defined in this block here. This curly brace denoted block scope. And a closure is where we have a function definition. Look at that. It's referring to that multiplier constant that is outside of its scope. But where is it? It's in the enclosing block. So effectively this multiplier has been closed over, and when this function is defined and then returned and captured in this add value added tax thing, we've got a function here in the form of make long taxa that is expecting an amount and is going to, we're going to have from it return some sort of value. But that function, when it was constructed, has access to the value at the time of multiplier, which is in the enclosing block. Okay, that is what a closure is. It's the ability, not the ability, but it's the concept of a function having access to values in its enclosing scope. Now, that's for those who are coming to closures for the first time. That's quite a lot to sort of think about. And it's 8:59, so maybe that's where we stop. So why do we metrics? Why do we need to learn this? Well, hopefully that will become clear over the course. I do think functional programming is a beautiful paradigm that allows us to think more clearly about the code, to write more stable, solid state code that doesn't move, that is less likely to break, that is more easy to reason about and more reliable. So hopefully that answers that question a little bit, but give it time over the course of the series of this, what we're doing here, and hopefully we'll understand that together. So for us to be more flexible in producing quality. Yes, brilliant answer. A better answer than my answer. Thank you, Bern. Andrew Bernard. Multiply is in make long taxes backpack. Oh, I love it. I love it. So closure equals function as a return value of another function. No, a closure is effectively this sort of concept, this construct where functions can get access, or functions have access to values in their enclosing scope. Okay, we'll carry on with this. We'll carry on with this next time. It's going to be in 2 or 3 weeks' time because I'm away now. But hopefully that was not too chaotic a start. Thanks for joining. Have a great Friday. Have a great weekend. And yeah, I'll see you very soon. Happy functional programming. Bye for now.